Okay, so in this video we are going to be talking about the coordinate geometry. Okay, coordinate geometry, it's a topic that you're going to find not only just in mathematics but also additional mathematics. Okay, so under the coordinate geometry there are a couple of things that we normally discuss, that we normally look up into. Things like the gradient, the equation of a line, the midpoint, provided that you've been given two coordinates, and we also find ways in which we can determine the area of a triangle, okay, under the coordinate geometry, and we can also be tasked to determine the distance between any two given points. Okay, so the kind of coordinate geometry that we're going to be talking about here is coordinate geometry in 2 dimensions, meaning that we are only going to be referring to the x and y axes only. Okay, the x plane and the y plane, that's where our focus is really going to be on. Okay, so just an introduction, I want you to understand that a coordinate is always written in the form x comma y. Okay, so a coordinate is always written in the form, let me write it here, a coordinate is always written in the form, a coordinate is always in the form, written in the form, always written in the form x comma y. Okay, a coordinate is always written in the form x comma y, which means that you can be given your y-axis in this way. So we normally use coordinates to determine the location of a particular point. So maybe here this can be like 1, 2, 3, 4. This is like 1, perhaps here 2, maybe here 3. So you can be given maybe say a point here. You can call this point as point A. Maybe another point here, which we can refer to as point B. Okay, so how can we determine the coordinates of these points? Remember, we are saying that a coordinate is always written in the form x comma y. So if you're trying to write the coordinates of A, just look at where it is in the x-axis. In the x-axis it's simply on 2, so this is going to be like 2 comma, you're going to see that in the y-axis. So this is the y-axis, this is the x-axis. So in the y-axis it's on the position number 1. So that's it, that's the coordinate of point A, 2 comma 1. If you're talking about point B, how we can determine? Well, we can do it in the same way. Look at where B is in the x-axis. In the x-axis is on 3, right? So you write 3 comma. In the y-axis it's also on 3. So the coordinate of B is 3 comma 3 in that way. So that's how we can determine the coordinates of some points if you have been given an x or y plane and you're being asked to determine the coordinates of some points like A and B here. So A is just going to be 2 comma 1, B is going to be 3 comma 3. Not forgetting this very important point to say that a coordinate is always written in the form x comma y. In other words, you always need to start firstly by writing your x value and then you write your y value. Okay, so in this video what I'm just going to do is that I'm only just going to give an introduction. So what I'm just going to talk about in this video will be just the gradient. Just the gradient. How can we determine the gradient? how can we determine the gradient? That's the question that we're going to start asking ourselves. Well, firstly, when you're talking about the gradient is in many categories. We talk about how steep or how bent something is. Okay, when you're talking about the gradient, we're talking about how steep or how bent something is, in a way that when you're discussing about the gradient, it can be applied to a line. We can also talk about caves, the gradient of caves. But in this video, we're just going to be talking about the gradient of a line because it's way much more easier to explain as compared to caves. There is a lot of calculus involved there. So how this one is going to go now is like this. When you're determining the gradient of a line, the formula that we always use is m is equal to y2 minus y1 over x2 minus x1. That's the gradient formula of a line. M is equal to y2 minus y1 over x2 minus x1. So y2 minus y1 is the change in y. x2 minus x1 is the change in x. Okay, y2 minus y1 is the change in y. x2 minus x1 is just simply the change in x. So using this, we can be able to determine the gradient. I'll use these same coordinates, 2, 1 and 3, 3. If I join these 2 points together, what they're going to do is that they're going to form a line. So we're going to determine the gradient of this line. It is bent. Have you seen that? It is bent. So because it is bent, it's not vertically upright or horizontally straight. So because of that, this thing tends to have a gradient. But if it's horizontally or vertically straight, well, there's some other concepts that you need to know there, which I'll just explain in a moment. So m will be equal to y2 minus y1 over x2 minus x1. So remember, a coordinate is always written in the form x, y. So this is going to be your x, y, even here x, y. But remember, there are 2 x values and there are 2 y values. So it can be x1, y1, because this is your first coordinate. This is going to be x2 and then y2. Alright? So x1, y1, x2, y2. If you want, your gradient formula can be written in a different way. If you want, you can write it as m is equal to y1 minus y2 over x1 minus x2. Whether you write it in this way or in that way, it's just going to be one and the same thing. The value that you're going to have will just be the same. Okay? So this is now going to be like this. So take note, I have changed everything. It's y1 minus y2. Even down here, I have changed x1 minus x2. So if you want, you can write it in this way, or if you want, you can write it in that way. So m will be equal to, your y2 is 3 minus your y1 is just 1. So 3 minus 1 over your x2 is 3. Your x1 is just 2, as we had written there. So 3 minus 1, the answer is just going to be 2. 3 minus 2, the answer is definitely going to be 1. 2 divided by 1, the value is just going to be 2. And that's it for this problem. You have simply determined the gradient of this line that you have been given there. What other key things do I want you to know? If the line is increasing in this way, the gradient will be positive. If the line is in this way, in this format, like it's decreasing, the gradient will be negative. The other key thing that I also want you to understand is this. If two lines are parallel, that is, they are not meeting each other and proceeding in the same direction. So there is a big difference between two lines being parallel and being anti-parallel. So if two lines are parallel, they are not meeting and they are moving in the same direction. If they are anti-parallel, it means those two lines are not meeting and they are heading in opposite directions, which means that if one is going to the right, the other one should be going to the left. Okay, if the other one is going to the left, the other one should be going to the right. This is what we mean when we say that two lines are anti-parallel. But if they are parallel, like in this case, you're going to see that these two lines are simply heading in the same direction. So if two lines are parallel, one thing that you need to know is that their gradients are always going to be the same. So let us think of this line as line 1, and this one down here, let this one be line 2. And let the gradient of line 1 be m1. The gradient of line 2, let it be m2. Because these two lines are parallel, this means that the gradient of 1 is going to be equal to the gradient of 2. That is, the gradient of line 1 is going to be equal to the gradient of line 2. So this is another concept that you need to know if two lines are parallel and you're discussing the gradient. Okay, gradients of two parallel lines are the same. The last one. If two lines are perpendicular, what do I mean? Two lines which are perpendicular always form a 90 degrees angle between them. So let this be line 1. Let this be line 2. If these lines are considered to be perpendicular, it means that they are making or forming a 90 degrees angle between them. What's the relationship between their gradients? The gradient of line 1, if multiplied with the gradient of line 2, the value always comes out as -1. The gradient of line 1, if multiplied with the gradient of line 2, the value always comes out as a -1. This is very important. In other words, the gradient of line 1 is just simply a negative inverse of gradient 2. Here, the gradient of line 2 here is just the negative inverse of the gradient of line 1. The gradient of line 1 is the negative inverse of the gradient of line 2. This is all summarized here in m1 times m2 is equal to -1. In case you're given a scenario where maybe say you know the gradient of line 1, let us imagine maybe say line 1 has a gradient which is equal to 4. What you're just going to do is that you're just going to get this value 4, you're going to put it on m1, and this is going to be 4 times gradient 2 is equal to -1. 4 times gradient 2, this is just going to be 4 gradient 2 is equal to -1. Divide both sides by 4, you're going to see that this is going to be m2 will be equal to -1 over 4. Yes, have you seen? This gradient 2 is just simply the negative inverse of that guy, which is there. So line 1 and line 2 do not share the same gradients, and moreover, the values, the nature of their gradients are also different. If one is positive, the other one is going to be negative, like I had shown you here. If a line is increasing, just like this one, if the line is increasing, then the gradient is going to be positive. If the line is decreasing, the gradient is going to be what? It's going to be negative. Very important that you understand these concepts. If you look at it, the nature of 1 and the nature of 2 are completely different, which means that the nature of their gradients are also going to be different. One is going to be positive, the other one is going to be negative. So this is what we can say concerning the gradient of a line. This is what we can say. Oh yeah, and just simply not forgetting, if a line is vertically straight, such kind of a line has no gradient. In other words, the gradient is undefined. The gradient is undefined if it's vertically straight. The gradient is going to be undefined. But if a line is horizontally straight, the gradient is 0. So there is a big difference between this and this. If the line is vertically straight, it has no gradient. If it is horizontally straight, the gradient value is going to be equal to 0. So that's what we can say to serve as an introduction to the coordinate geometry, and also how you can determine the gradient of a line and some other key concepts that you need to understand about the gradient. Thank you very much.